Good day everyone, welcome to BSABE-A Tutorials. In this video, we will solve a fluid mechanics problem from the book of Yunus A. Senjal and John M. Simbala. Chapter 2, Properties of Fluids, a compressibility problem, 2-40. So in this problem, water at 15 degrees Celsius and 1/8 atmospheric pressure is heated to 100 degrees Celsius at constant pressure. Using coefficient of volume expansion data, determine the change in density of water. So in this problem, we have the given pressure 1 is equals to 1 atmospheric pressure and temperature 1 is equals to 15 degrees Celsius and temperature 2 is equal to 100 degrees Celsius. So for our solution, water at a given temperature and pressure is heated to a higher temperature at constant pressure. The change in the density of water is to be determined. So we have two assumptions here. Our assumption 1 is the coefficient of volume expansion is constant in the given temperature range. Assumption 2, an approximate analysis is performed by replacing differential changes in quantities by finite changes. So the properties, the density of water at 15 degrees Celsius and 1 atmospheric pressure is the density is equals to 999.1 kilogram per cubic meter, or that is equal to 1000 kilogram per cubic meter. And the coefficient of volume expansion at the average temperature of 15 plus 95 all over by 2 is equal to 55 degrees Celsius. And the beta is equals to 0.484 times 10 raised to negative 3 Kelvin raised to negative 1. So our analysis, when differential quantities are replaced by differences in the properties alpha and beta are assumed to be constant, the change in density in terms of the changes in pressure and temperature is expressed approximately as the change in density is equal to alpha times density times the change in pressure minus beta times density times the change in temperature. The change in density due to the change of temperature from 15 degrees Celsius to 95 degrees Celsius at constant pressure is, we have the formula, the change in density is equal to negative beta times density times the change in temperature. So plugging in all the given, we have negative 0.484 times 10 raised to negative 3 Kelvin raised to negative 1 multiplied by 99 9.9%. 999. Manguha. Ulit. Start ko sa 35. The change in density due to the change of temperature from 15 degrees Celsius to 95 degrees Celsius at constant pressure is, we have the formula, the change in density is equals to negative beta times density times the change in temperature. So plugging in all the given, we have negative 0.484 times 10 raised to negative 3 Kelvin raised to negative 1 multiplied by 999.1 kilogram per cubic meter multiplied by 95 degrees Celsius minus 15 degrees Celsius Kelvin, we get negative 38.7 kilogram per cubic meter. So nothing that the change in density is equal to density 2 minus density 1. So the density of water at 95 degrees Celsius and 1 atmospheric pressure is density 2 is equals to density 181 plus the change in density is equal to 999.1 plus negative 38.7. We get 960.4 kilogram per cubic meter, which is very close to the listed value of 961.5 kilogram per cubic meter at 95 degrees Celsius in water table in the appendix. This is mostly due to beta varying with temperature almost linearly. Note that the density of water decreases while being heated, as expected. This problem can be solved more accurately using differential analysis when functional forms or properties are available. So that's it for today. Thanks for watching. See you again in our next one. Happy learning!